Hi, welcome to the Endisoft 2021 third quarter broadcast investor conference. To begin with, we'd like to introduce Endisoft management team in this conference. We have Endisoft CEO and Chairman Frank Lin, Associate Vice President of Finance Department, Ms. Fiona Zhou, and Special Assistant Vincent Chen. Today's meeting will be hosted by Chairman Lin. He will summarize our operation in the third quarter and provide you key messages. After the briefing, there will be a Q&A session. Please feel free to submit your questions by text during the process of the conference. To begin with, we'd like to remind everyone that today's presentation may contain forward-looking statements that are subject to risk factors related to the semiconductor and IP business and uncertainty which could cause actual results to differ materially from those contained in the forward-looking statement. Please see the risk precaution statement on the PowerPoint slide. Now I'd like to hand over to the CEO and Chairman, Frank Lin. Thank you, Frank.
Thank you, Charlene. Good afternoon, good morning, and good evening, everyone. Today, I'd like to share with you company overview or operation results for the last quarter, then coming with product applications, new products and ecosystems, and giving some conclusion remarks. So let's begin with company overview. First, Endisoft highlight. We were founded in March 2005 in Hsinchu Science Park. It is a well-established company now. We are a pure-play CPU IP provider. We went to IPO in 2017. Today, we have over 240 employees worldwide, and 80% of them are engineers. We won TSMC OIP Award of Partner of the Year for New IP in year 2015. And we started to be a founding premier member of the RISC-V International Association since year 2020. We won AI Global Media Award of Most Outstanding Embedded Processor IP Supplier in 2020. For year 2020, we also won the award from Hsinchu Science Park for Innovation Award based on our Endisoft Core NX27V. Then this month, we won the EE Times Award for Taiwan Product Awards based on NX27V and the Asia Company Award. Then I'd like to give you some update overview. Currently, we have more than 200 commercial licensees worldwide. Our IDE, which is an integrated developing environment, has been installed with more than 21,000 sites. In each installation, we believe there are more than 5 engineers learning Endisoft. In our ecosystem, we have more than 500 partners worldwide. Up to today, our customers accumulated, shipped more than 9 billion SoC to the world. Then let me give you some operation result. For third quarter, the revenue was 192 million, which is a little bit like then the second quarter, about 7.3%, but largely a growth from last year, YOY comparing, it's 83.5% growth. Continue with the revenue analysis. For first quarter to third quarter, the accumulated revenue is 550 million NT dollars, which is a 76% YOY growth. In this slide, we like to analyze top 10 customers ranging from different application. The first one is a US company. Their application is AI. Number 2 customer based in Taiwan for touch panel. Number 3 based on Taiwan application wireless IoT. Number 4 sensing application. Customer is in Taiwan. Number 5 application is 5G modem. The customer is in China. Number 6, the customer is in United States. Their application is MCU. Then from number 7 to number 10, they are all in China. Number 7 application is AI. Number 8 customer, their application is 5G modem. Number 9, their application is server. Number 10 application is Wi-Fi 6. And with these 10 customers, they contributed 61% to our overall revenue. For royalty analysis, in third quarter, the income is 65.6 million, which is a 29.9% growth from second quarter, and 77% growth YOY. Further analysis for royalty, year to third quarter, the accumulated revenue is 170.9 million NT dollars, which is a 70% growth YOY. Now let's analyze the contribution from customers who started to pay royalty. In the pie chart, we can observe that top 10 royalty customers contributed 89% of the royalties. From first one, which is based on Taiwan, the application is touch panel. Number 2, also in Taiwan, sensing application. Actually, top 5 are in Taiwan. Number 3, application is a wireless IoT. Number 4, gaming. Number 5, application is also touch panel. Number 6, customer is in China. Their application is storage. Number 7, based in Korea, their application is touch panel. Number 8 is in Taiwan. Application is wireless IoT. Number 9 from China, application is wireless IoT. Number 10, also in Taiwan, application is wireless audio. So in this slide, we like to mention that from the statistics, year to third quarter, the total revenue is already higher than overall revenue in 2020. So the growth is significant, and the customer numbers is yet to be listed here, but we believe the number will keep growing. Now let's analyze margin. For gross margin, it keeps the same, always higher than 99%. For a consolidated gross margin, similar. In terms of operating expenses, in third quarter, there's a growth of 22.1%. We can observe that the significant growth in R&D expenses and selling expenses. Comparing to last year, YOY, the growth is 11%. And again, the growth comes from selling expenses and R&D expenses. In this page, we further analyze consolidated operating income. For a third quarter, it's 23.4 million NT dollars, which is a minus 66% down and from second quarter. However, it's a significant growth from last year, which is minus. Then compare year to third quarter, YOY, it's high growth now become positive. The consolidated operating income is 105 million NT dollars in year to third quarter. So the operating margin for third quarter is 12.18%, which is down from 33% from second quarter, but it's a growth about 38.8% YOY. I'm sorry. Then the margin for year to third quarter, for this year, it's 19.2%, which is a high growth from minus 28% from last year. Then consolidated net income for third quarter is 43.8 million, which is down 27% from QOQ, but a high growth from last year, minus 29.4 million NT dollars. So accumulation for Q1 to Q3, it's 131.6 million, a high growth from last year, minus 84.8 million. Okay, the net profit margin, the consolidated net profit margin for third quarter, it's 22.8%, which is a minus 6% down from second quarter, but it's a high growth from last year. The rate is 50.9%. Consolidated net margin, net profit margin for year to third quarter is 23.9%, which is a 51% YOY growth. Now, for consolidated EPS, in third quarter, it is 0.99 NT dollars. Comparing second quarter, it's a minus. I'm sorry, I found a mistake here. It's a minus 0.42. However, it's a growth from last year. YOY comparison, 1.68 NT dollars gross. So for year to third quarter, the consolidated EPS is 3.05 NT dollars, which is a 5.04 NT dollars growth from last year. Okay, now let's analyze first quarter to third quarter revenue by payment model. 56% coming from license fee, 31% from running royalty, 9% from maintenance, 4% from custom computing service. If we analyze the revenue by region, 38% from Taiwan, 33% from China, 21% from USA, 4% from Japan, 3% from Europe, and 1% from Korea. Now, comparing RISC-V and V3 for first 3 quarters, 61% of the revenue from RISC-V, while V3 contributed 39% of the revenue. Talking about the top 5 products, the ranking from top 1 is N8, then N25, AX45, NX27, and number 5, N9. Let's talk more about comparing V3 and the RISC-V. In this chart, we can analyze that in each quarter, the percentage between V3 and the RISC-V is obviously now RISC-V leads. And we compare the ratio between V3 and RISC-V for this year and the last year. And the growth is obvious. For first 3 quarters, RISC-V shared 61% of the revenue. Okay, then let's talk about the product application. For past 16 years, we have been contributed many CPUs to the world. The application has been reached more than 200 kinds of different applications. So it is well distributed from almost everything in mobile phone to IoT to car application to gaming, then machine learning, switch router, networking and telecommunication, 5G, Wi-Fi 6, Wi-Fi 7, and AI processors. Okay, from MCU to data center, you can see everywhere our RISC-V products can contribute. Now let's talk about the new products and ecosystems. This is the way we do business. We start with architecture. We do processor design. We provide hardware developing platforms and software developing environment. We also support a software stack for operating system to middleware to library, then to application. So currently, Endis has been devoting its effort more in RISC-V. For different kinds of level of computing requirement, say a conventional computing architecture to if better power performance area feature required, our high performance yet power efficient application processor required, and to the scalable vector processor, super computer style of vector processing. We all have a different RISC-V processors to be the core of SoC. Also, we see domain-specific architecture application as a dominant, a significant application for now. So it is a good place for the significant feature of the RISC-V, which is aiding new instruction to the system by engineer. We see that as important, so we developed the tool chain. We call it ACE, Endisoft Custom Extension, for them to apply. So in this chart, we like to share the product roadmap of Endisoft CPU cores. Let's see this graph from entry level 22 series to a fast yet compact CPU with FPU and the DSP series, 25 series. In 25 series, we also have products which come with Linux operating capability with FPU and the DSP. We also provide cache coherent 1 to 4 core multi-core processors in 25 series. And among them, there are 32-bit cores and there are 64 cores, 64-bit cores. Then we migrate to a better memory boost feature, 27 series. In 27 series, we supply 32-bit and 64-bit CPUs for 27 series, one series with level 2 cache enhanced. We also are the first one to provide a commercial vector extension, which is a vector processor to the RISC-V CPU line. We call it the NX27V. Then Superscalar Series 45, we add the dual issue feature to it, also with memory boost feature. So there are quite a few cores here, from general purpose computing to core with DSP or that can run Linux, then to multi-core, 4-core processors. And again, with ACE, what's the importance of ACE? It is the way to unlock RISC-V's potential. Like I said, for domain-specific application, it is for define ACE instruction to handle time-critical codes, and for our customer to add their coprocessor or accelerator to RISC-V CPU. And this provide the all-in-one Copilot developing environment to this kind of application. Now, I like to spend more time in our 45 series. There are 32-bit series and 64-bit series. This is a general purpose product block diagram. In general, it comes with 8-staged pipeline architecture in order computing with a dual issue. Okay, the ISA, RISC-V ISA, and Endisoft ISA supported, including RISC-V 32-bit and 64-bit G, C, N, which means the general purpose computing instruction sets in RISC-V. Also, P extension, which means SIMD DSP application instruction sets. And then coming with the MMU for Linux running capability. So you can refer to the right side with the broad diagram. It comes with MMU if it's A series. It comes with FPU and DSP, branch prediction, I and D cache, I and D local memory. It also comes with fast or small multiplier, unaligned data accesses, and the low power dynamic branch prediction capability. Memory boost, memory subsystem is a default. We also add Endis extension for stack safe and code dense. In this chart, we like to say that for our 45 series, if we compare that to our own 25 series, it's more than 50% of performance up for Drashstone per megahertz or core mark per megahertz branch marks in 32-bit or 64-bit, both. It's more than 1.5 time growth. That's a comparison inside Endis. Now let's compare with competitors' core ARM. If we compare Endis AX45 with ARM's A53, they both are 8 stages core in order dual issue design, but we perform better. For AX45, it is 37% faster in Drashstone MIPS per megahertz, and 32% higher speed than A53 if comparing by core mark per megahertz. So what is the target application? AI, deep learning, AR, VR, 5G, together with high performance computing, HPC. I believe these are the building factors of the metaverse. Metaverse became quite popular and hot in recent months. However, for us, the starting of building the competitiveness to help our customers be able to build a metaverse, we already started several years ago. The target application includes networking, storage, video surveillance, automotive application like ADAS, or vehicle to everything networking, or in vehicle infotainment application. Now, talking about general application to high performance application, in the bottom of this slide, we can see, we can analyze the application by the speed, the data rate, the rate we manage data from million operation per second to giga operation per second to a trillion operation per second. So for different kind of category of application like smart IoT devices, smart camera, smart home, mobile, AR, VR, surveillance, automotive, and data center, different kind of category application require different kinds of management of data accessing and managing rate. We can see this as this perspective by different CPU to deal with different kind of data rate. For every series of ND's RISC-V CPU, you can do that. So next, I have a few slides to share with the competitiveness ND's built for AI application. And this is the first one to implement RISC-V DSP P extension, because ND's is a leader in this category for task force in RISC-V International Association. We are able to provide a compiler that can automatically generate partial RVP instructions to facilitate customers' development. We also provide DSP intrinsic functions. It is a C-like functions without writing assembly. We also provide DSP library to customers. I will have analysis on that. So with this, we help to increase power efficiency by 2 times to 15 times as follows. For MP3 decoder to LC3 plus codec, you can see that for pure C implementation, comparing with that, we are able to help to boost 2 times to 5.5 times. For different AI application, say keyword spotting, face detection by PNet algorithm, image classification by CIFAR10 algorithm, we can boost 8.9 times to 14.8 times. Now, talking about Endisoft Dsp Library, it is a highly optimized low-level DSP functions for P extension processor. It provides near 300 functions in 10 categories. It is also a superset, but yet compatible with ARM's CMSIS DSP API. So it can help to boost signal processing performance. If we compare ARM's processor M4 as 1, then our 32-bit D25, D45 can boost 1.6 times to 2.3 times. Our 64-bit AX25 and AX45 can boost 2.4 times to 3.5 times. So from DSP, now let's talk about a vector processor. In ND's, we provide an NX27B, a Cray supercomputer style of vector processing unit, from as large as a room like a Cray computer now to as small as nanometers in a chip. Okay, there are 3 options for customers to choose compute data widths, which we call the configurable compute data width, VLAN. The length could be 128-bit, 256-bit, or 512-bit. So the application could be wide as from endpoint computing, edge computing, to cloud computing. Now, combining high performance computing, I like to use this slide to explain further. How do you build high computing power? So let me introduce AX45MP 4-core processor and NX27B vector processor as the building blocks for HPC. In AX45MP, if it runs 1 gigahertz, it could deliver 64 giga operations per second. Let me explain. In each single core AX40MP1C, it can operate 8 by 8 multiply and accumulate. This kind of instruction means multiply and accumulate data. It can be counted as a two operation per second. So 8 by 8 times 2, it could deliver up to 16 giga operations per second at 1 gigahertz. 16 multiplied by 4 core, that comes with the 64 giga operation per second, as I mentioned. That's for the 4-core processor. Now, if we talk about the NX27B, if we run it at 1 gigahertz, the measurement, the simulation indicates that we have a table here. It could deliver 96 gigaflops and 320 giga operation per second, GOPS. And then it could be higher if you leverage 5 nanometers process to boost the frequency. So the gigaflops it can deliver becomes 110. The GOPS it can deliver becomes 368. So the general rule is a higher frequency, you get higher GOPS and the GFlops. So the computing power is thus built and stacked by these two kinds of core you apply. Then what do we use that? How we use that? Remember we had this slide. In every kind of application, you require different kind of computing powers. So for AI and HPC, you require trillion ops or even a trillion flops. So I'll keep giving you example how we build that, how we help customers. Today, we have many customers. They leverage Endisoft core to build their SoC. In their SoC, it could be a single core building. It could be a few cores building, like 2 core, 4 core, or 8 cores. But we see a customer already built 32 cores in a chip, 128 cores in a chip. And we have customers building in the chip with more than 1,000 cores, Endisoft cores in a chip. How do they do that? Let me give you an example. We have to build the base of an application. We need a scalar. So we use Andy's RISC-V core as a scalar 1 or 2 or 3 by apply different kind of ACE, which means we encourage customer to add their new instruction to different scalar, so they become different kind of a building block. Then we insert each scalar together with customer's convolution logic to be the PE. PE is an element if you are familiar with the CNN algorithm. For CNN algorithm, you need this kind of building blocks with a scalar and the convolution logic. Then you can apply 32, 64, 128, or 1024 element like this one. You could apply them to audio recognition or SSD, deep learning, inference engine to AI data center server. This is the way customer use it in AI and a high performance computing application. Beyond that, we also need to help customers with the ecosystem. Let me use 2 slides to help explanation to you. Everybody leverage open source frameworks. In this case, let's use Google's TensorFlow as an example. By leveraging Google TensorFlow framework, you can get an NN model. You input that to TensorFlow Lite, so you get a runtime. And this already have the ecosystem built that the flow has been punched through. So you can leverage a TensorFlow Lite micro reference closer to directly run on Endisoft baseline, or you can leverage our NN library provided by Endis with optimized kernels to RISC-V P extension or RISC-V V extension, which is a DSP or vector processor, or the NN hardware engine customer may design. This is the first example. Second example is like this one. The AI, the software stack and ecosystem for AI application. Again, everybody leverage open source AI frameworks like TensorFlow, PyTorch, Caffe, and etc. So you can use that to generate a model. You can have our partner to help with a model optimization. Then leverage Andy's ecosystem to do the inference engine. Then we provide LLVM compiler and OpenCL environment to take the input so they can run vector library, NN library, or DS library in our different kinds of CPU, DSP processor, or vector processor, and so on. So that's the example I like to share with you. Now let's go into make a conclusion because I run out of my time. I go directly to the conclusion. Endis tries to be a computing expert which can be trusted. We provide a reliable product lines. Our business model is reliable. Our position is reliable. We hope that by providing RISC-V CPU solution and ecosystems to our customer to help them with SoC time to market, so they can ramp up mass production and make their profit. Okay, that's my presentation for today.
Thank you, Frank. And ladies and gentlemen, thank you for joining us today. The broadcast will be recorded and upload to Endis company website within 3 hours. Welcome to visit our website, www.endis.com. See you next time. Goodbye, and we wish all of you have a good day. Thank you.
Thank you.